Okay, so I'm going to illustrate here inheritance, which you probably already know a little bit about, but in particular dealing with subclasses and interfaces. So we've created a shape interface. If you watch the last video, and actually we turned it into an abstract class. So we have the shape, and you cannot instantiate a shape, an abstract class, or a um, interface. I can show you that. Shape A equals new shape. Shape is abstract, not instantiated. Now, one thing to show you here is that I can create a rectangle. The length is 5, width is 4, and attach it to shape here, and that compiles. So shape A equals new rectangle 5, 4. Okay. So, and I could also do shape B equals new rectangle, or let's say new circle 6. Okay. So those are not allowed. You're able to basically a second type for this object is a shape. It can only run or it's a circle, but it can only run the methods that are in shape. So basically, get area, get perimeter, or we also did that ratio of area to perimeter. Now, if there was another method we supplied in the circle class, like let's say get the diameter, was only specific to the circle class, then you could not run it here, it being attached to shape. It can only run the methods that it overrides through shape. Okay, so that's one thing to know. We'll talk a minute about why we want to do that. Another thing I'll show you is this is not going to work. Okay, again, we're trying to instantiate a shape, which it can't be done. Okay, so, and even if this was a class, not an abstract class, this whole idea of declaring an object with two different types only works if this one right here is a subclass of this one or implements. Okay, underneath it. It can't be above it. So in other words, even if shape was a regular class and rectangle was a subclass, this would not compile. Okay? It has to be in this way where this is the one below and this is the one above. This is the more general class. Okay? So notice that doesn't work. It only works like this. You also can't, which you probably understand, rectangle C equals new circle. That definitely isn't going to work. Because really those two classes, they extend the same class. They're both shapes, but they're not related other than that. Okay? So a circle is not a rectangle is not a circle. Okay, so you can't do it. And really, again, just since I used the word is a or the phrase is a there, this whole idea only works if this is a this. So if a circle is a rectangle, which it is not. A circle is a shape, a rectangle is a shape, so those work. Now, let me just do another one. I'll do a couple here. Okay, so I got 4 shapes. Okay, now why do we even want to do this? Well, this is going to be a pretty simple example, but even though we cannot instantiate a shape, we can create an array or array list of shapes. Okay, and since I'm doing an array here, I have to define the type, or actually, no, I can just do this. There's my array. And check and see if that compiles. It does. So A, B, C, D are all shapes, and I can put them in an array of shapes. Okay, so there's only 4 of them, so it wouldn't take very long to do this manually. But let's just say I wanted to get the area. Let's just say I wanted to print the highest area of these shapes. Well, they all get shapes differently. So let me do int highest equals 0. Shapes dot length. This is an array, not an array list. And if shapes bracket I, that's going to give you each individual shape. Dot get area is greater than highest, and this should be a double. Then I'm just going to set highest, and all I want to do is print out the highest area. I don't have to know which rectangle or circle it came from. I'll just print out the highest area. Yeah, for right now that's fine. So highest equals shapes bracket I dot get area. Okay, so basically it will check all the areas for A, B, C, D, and the first one, if it's higher than 0, it will become the highest, which guaranteed A is going to become the highest on the first pass. But then after that, B, C, and D will be compared against whatever the highest area is for that pass. And at the end of that loop, the highest area will be whatever the shapes that have the highest area. Let me print out. So this is the benefit of one benefit of interfaces and abstract class. It gives us this secondary data type, and we can create these lists of that data type, and they're really mixed. So in other words, all these are shapes and rectangles and things like that. Okay, the other benefit of interface and abstract method is, or especially the interface, is that you have to supply the code for those methods. So if you implement shape, you have to make it's another check. You have to give it an area, get area method, and you have to give it a get perimeter method. So let's make sure this works. I don't even know what the highest area would be. I know the rectangles are 20 and 27. Oh, the circle. This circle will be much bigger because it's 36 times pi. So whatever 36 times pi is, that's what we should get here. That's about right, 113. So that was the highest area. Now, one more thing before this is over. This concept, which is a pretty simple concept, but it's got a big name and it can be confusing, is called polymorphism. And all polymorphism means is this. When we run this get area method on a shape, we are calling the shapes get area method. But Java uses the correct get area method for a rectangle versus a circle. It uses the rectangle's area method, uses the circle's get area method when it's appropriate. That is called polymorphism.